Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, from past 2 days we have been discussing about the chapter number system. Let us go for continuing this. Before that, just we shall recall some of the important points what we discussed in yesterday's class. The very first point, there are infinite number of rational numbers are there between two rationals. And second point, root 2 is an irrational number. It was discovered by the Pythagoreans. They are the followers of Pythagoras. Then third important point is, one of the Pythagorean is Hipparchus of Croton had an unfortunate end for disclosing root 2 is irrational number. Then after that, and fourth point is, another mathematician is Theodorus of Cyrene had shown that root 3, root 5, root 6, root 7, root 10, root 11, root 12, root 13, root 14, root 15 and root 17 are irrational numbers. Then in the next part, that is fifth point, we got information about number line and how to represent numbers on the number line. And this was introduced by two mathematicians. One is Richard Dedekind and second one is G. Cantor. Then yesterday we just focused on how to represent irrational number on the number line. Among them, one is root 2. We learned how to locate root 2 on the number line. Now in today's class, let us go for continue to represent some other irrational numbers on the number line. Yes, just only one question was taken. Now write down second one. Locate root 3 on the number line. Yes. Here I hope that you are all ready with instrument box. We need geometrical instruments to locate root 3 on the number line. Now I am going to take first scale. You have to take a scale. Don't go for constructing with me. After construction is over, you have to pause the video and go for copying that in the notes. Now here I'll draw a line. You have to draw a straight line. Then go on marking for unit distances. Here I am taking for every 20 centimeter as 1 unit. But in your scale, you can go for taking every 2 centimeter as 1 unit. Here this is 0, it is 1, this point is 2, this point is 3. On the left side of 0, they are negative. I'll write negative 1. Then without fail, we have to write the scale that we have used. Scale is 1 unit. It is equal to how much? It is 2 centimeter. Next, take the 0, the point which represents 0 as A. Point which represents 1 as B. Call this as 1 unit. We have already learned how to locate root 2 on the number line. First, if you want to locate root 3, first we have to locate root 2. Here, let us take the protractor. Observe. And mark against 90 degree. Take scale, draw a perpendicular line at B. As it is perpendicular, without fail you have to show this symbol. Next, take a compasses. Take the unit distance, that is AB. Next, with B as center, draw an arc which cuts the perpendicular line at a point. Call this point as C. Join AC. So where AC is root 2. Yesterday only we have come to know that. Root 2. And what about this? This is 1 unit. Then you are going to represent root 3 on the number line. Hence it should be continued. Again you have to take the protractor and place the point exactly at C along the line. See that along the line AC, mark against 90 degree. Take a scale and draw the perpendicular here also. Then mark the perpendicular without fail. Next, again you have to use the compasses. Already you have taken 1 unit distance. The same thing should be used. Same distance should be used. Then with the C as center, draw an arc which cuts the perpendicular at D. Let us join AD. Now, what about this? CD. CD is 1 unit. Please do remember, see, this is 1 unit, this is 1 unit, and even CD is also 1 unit. What about AD? Can we say that it is root 3? We do not know. So, we will go for checking that whether AD is root 3 or not. Hence, we will go for using Pythagoras property that we have already learnt in yesterday's class. In triangle, that is last triangle, ACD, in triangle ACD, angle ACD equal to 90 degree by Pythagoras theorem or Pythagoras property. How do you write? The square on hypotenuse. Which is the hypotenuse? AD. The square on hypotenuse is equal to the sum of squares of other two sides. AD square is equal to AC square plus CD square. AC square plus CD square, where AC is how much? Root 2 whole square plus CD is how much? 1 whole square. Now square and root get cancelled. It is 2. 1 square is 1. 2 plus 1, 3. AD square is 3. AD is equal to root 3. Got it? Now AD is root 3. Now this root 3 should be represented on the number line. So I go for taking the length, that is AD. This length, that is AD length, should be represented on the number line. You may draw an arc with A as center, AD as radius. Draw an arc. Yes, this is the point. I am going to marking it. You may just you can just draw an arc which cuts the line. This is the point which represents root 3. This is the method of locating root 3 on the number line. Understood? For your construction, you can give the justification like this by using Pythagoras property. Okay. So now you have to pause the video and should construct it. Then after construction is over, you have to play it. Now I'll go for another one. Third one, it is important one. Third one is, this time we are going to locate root 5 on the number line. How to locate root 5 on the number line? Again same thing. If you want to locate root 5 on the number line, first you have to construct up to root 4. To construct up to root 4, you have to construct root 3. And to construct root 3, you have to construct up to root 2, like this. So, I'm going to continue this one only. Yes. Okay, let us locate root 5 on the number line. Then you have to draw a line like this. Go on marking for every unit distances. That is for every 2 centimeter. If the distance is more, it is more comfortable for construction. Then mark 0, 1, 2 and 3. On the left side of the 0, minus 1. Then at point, the point which represents O, call it as A. Which represents 1, call it as B. It is 1 unit. Then draw the perpendicular line and mark it for 1 unit. Then join AC, you will get root 2 that we have already learned. Next, again draw perpendicular line at C and draw an arc of unit length which cuts the perpendicular. Then join AD. AD is also root 3. Now, to get root 5, it should be continued. Now I am going to continue this. Again, at D, see that root 2 is over, root 3 is over. Next, root 4. At D, mark against 90 degree. Draw a perpendicular. Show the perpendicular symbol without fade and call this point as E. What is the distance of ED? That is 1 unit. Then join AE. AE is how much? It will be root 4, nothing but just 2. Because when you apply Pythagoras theorem, see that root 3 whole square plus 1 square. Root 3 whole square is 3. 1 square is 1. 3 plus 1 is 4. Hence it is root 4. Next, at E, now root 4 is over. We want root 5 at E. Place the protractor point at E and mark against 90. Take a scale and draw perpendicular and mark the perpendicular symbol without fade and call it as F. What is the distance of EF? It is 1 unit. Now join FA. Now what is this? Root 5. How? Of course, just again we can go for using Pythagoras, but here for the sake of justification, because you are going to represent root 5 on the number line, hence I will show that AF is root 5 with calculation. In triangle, what is the last triangle? AEF. It is a right triangle. In triangle AEF, angle AEF is 90 degree. So now I'll write by Pythagoras theorem. We can write square of hypotenuse. The last triangle, which is the hypotenuse. See that this is perpendicular, this is base, and hypotenuse. The side opposite to right angle is hypotenuse. AF square is equal to the sum of squares of other two sides. Other two sides are AE and EF. Alright. AE square plus EF square. It's equal to, what is the distance of AE? It is root 4 whole square. EF, it is 1 whole square. It is equal to 4 plus 1 square is 1. 4 plus 1, 5. Now AF square is 5. Then what about AF? AF is root 5. Then can we write the length of AF as root 5? Yes. Now this length, that is AF length, should be shown on the number line that we have drawn. Just recall the value of root 5. The value of root 5 is more than 2, right? And less than 3. So if you go for drawing an arc, that should come in between 2 and 3. Let us see. Here, you take compasses with A as center, AF as radius, you have to draw an arc. See, you have to draw like this. As the compasses is small, so it's not coming. It comes after 2. Just I'll show like this. This is AF and see that comes here. We can draw. Just I'm drawing, but you have to use compasses without fail. So this is the point. This is the point which represents root 5. Got it? So this is the method of representing root 5 on the number line. If you just go for continuing this, you will get the structure like a spiral. And this is called Theodorus V. What is that? Theodorus V means not just like an arc. Just I will show them. Here, see that? In this way. If you go on continuing this, you will get a spiral like structure, and this is known as Theodorus V. Theodorus V. You can try that in taking a separate sheet of paper. Just you may continue to construct like this up to root 12, root 13 like this, so that you can come to know how this Theodorus wheel will be. Followed? So now, pausing the video, you have to copy this. Now I'll move on to the next part of this chapter, right? Yes. And dear students, this is the spiral method. Now one more method is there. That is very simple. In a very simple way, you can go for representing root 5 on the number line. I'll show you that. Just I'll go for rubbing it on. Again we have to draw a straight line. And go on marking for every 2 centimeter. See, 2 centimeter, 2 centimeter, 2 centimeter. Again, I go for one more unit, 2 centimeter. You call it as 0. On right side of 0 are positive, 1, 2, 3, and so on. Then left side are negative, -1. Here I have written the calculation. You just go through that. I have written AF square is equal to AE square plus FE square. Now it is root 4 whole square plus 1 whole square. It is 4 plus 1. This is 5. Right? Then here, what is root 4? Root 4 is nothing but 2. Then can we say that it is AE is 2 unit? Yes. Understood? 2 unit and this is 1 unit. Together will give root 5 unit on applying Pythagoras property. Clear? I hope that you all have understood this. Now, hence, I go for taking the 2 unit and 1 unit. 2 unit is there on this number line. Here I'll write. I call this point as A up to 2 units as B. 2 units. Next, we want 1 unit. Let me mark against 90 degree at point B. Take a scale and draw a perpendicular line. Then take compasses and we want 1 unit only. Hence, I'll go for marking 1 unit on this perpendicular line. 1 unit is from 0 to 1. Then with the 2 as center, I draw an arc. Then call that point as C. Join AC. It is 1 unit. Then what about AC? Is it root 5? Let me show that with a calculation. Here I'll write. In triangle ABC, angle B is 90 degree. I'll write angle ABC is 90 degree by Pythagoras property. How do you write? According to Pythagoras property, the square of hypotenuse AC square is equal to sum of squares of other two sides. AB square plus BC square. What is AB? AB is 2 units. BC is 1 unit. So 2 square is 4, 1 square is 1, 4 plus 1 is 5, AC square equal to 5, hence AC equal to root 5. Got it? So I'll go for writing root 5 like this. Then you have to take, so you are going to mark root 5 on the number line. Hence we should take the distance AC and that should be, then draw an arc which cuts the number line here. I go for drawing lines. This is the point which represents root 5 on the number line. I hope you have understood this. Clear? Yes. And you have to copy this by pausing the video. Now, there are some, this is the method we can use for locating some more numbers which are in particular form. I'll tell you that. See that for representing root 2, you took 1 unit and 1 unit. Then for representing root 5, you took 2 and 1 unit. Likewise, to represent 10, 3 and 1 unit should be taken. To represent 17, 4 and 1 should be taken. Got it? Please do remember this. Now, I'll go for one more, that is root 17, because it was asked in the examination as well. Let me show how to locate root 17 on the number line. It is fourth one. I put double star mark as it was given in the examination. Root 17 on the number line. Here, first let us draw a straight line. and go on marking for every 2 centimeter. I'll start from here. Just keep observing. 1 unit, that's equal to 2 centimeter. Next 2 centimeter, again next 2 centimeter, next and next. I call this point as 0, this as 1, this as 2, this as 3, this as 4, and root 17, its value is more than 4, because root 16 is 4, root 17 is more than 4. The point should come after 4. It is minus 1. I call this as A. For root 17, what should be taken? 4 unit, because 4 square is 16 and 1 square is 1. 16 plus 1, 17. 4 units should be taken. 1, 2, 3, 4. 4 units. I call this point as B. The distance from A to B is 4 units. Next, at B, place the protractor and mark against 90 degree. Take a scale, draw a perpendicular at B. Then show the right angle symbol. Then take compasses and take 1 unit. These are 1 unit in this, and with B as center, draw an arc. On length 1 unit. Call this point as C. This is 1 unit. Let us join AC. In that direction only I am drawing. Yes. Now AC is root 17. That can be shown with the calculation. I'll write that calculation here. In triangle ABC, angle ABC equal to 90 degree. Then by Pythagoras theorem or property, you can write the hypotenuse AC square is equal to base AB square and the perpendicular BC square. What is AB? It is 4 units, 4 square, plus BC 1 unit. What is 4 square? 16. 1 square 1. 16 plus 1, 17. AC square equal to 17. AC equal to root 17. Now taking the compasses, we have to take a distance of AC. That much length should be there. Then as it is smaller one, just I go for drawing like this. But you must use compasses. It is root 17. I hope you have understood this. Okay. Now let's move on to the exercise. Again, to copy this, you have to pause the video. After completing it, again you come back to my explanation. Here, just before going to the exercise, one small information. If I ask you to locate root 10 on the number line, how many units you will take? It is 3 unit and 1 unit. If it is 17, 4 and 1. If it is 26, 5 units and 1 unit. Clear? Okay. Now you may write exercise 1.2. In that, the very first one is state whether the following statements are true or false. Write down there. First one, state whether the following statements are true or false. Justify your answers. Justify your answers. Copy. Now, in that, take first one. First one is every irrational number is a real number. Every irrational number is a real number. We know that. What is a real number? Real number that contains all rational and irrational. Whether it may be rational number and irrational number, that is called a real number. Hence, we can say that every irrational number is a real number. What is it? Whether it is true or false? It is true. Right. Answer, true. And the reason of justification, because here I right. Because real numbers contain irrational numbers, including rational, contain rational and irrational. Now, second, right. Every point on the number line, every point on the number line is of the form root f, where m is a natural number. I hope that you have understood the statement. Every point on the number line, if I go for taking a number line like this, here in the number line there will be 0 on the right side of the 0, 1, 2, 3 and so on. Left side of 0 are -1, -2, -3. Every point on the number line is of the form root m. Look here. When you go for taking the points between any two numbers, infinite number of points will be there. Here they are asking that every point on the number line is of the form root m. Suppose you go for taking root 4 square root m, where m is a natural number. It may be root 1, root 2, root 3. What is the value of root 1? 1. The point is on the number line. Root 2, its value 1.4142. Of course, just we have represented its value. It may come here. Root 3, it is 1.73 and so on. That may come here. Root 4 is here. But here many points are there other than these. Then whether the given statement is right, every point on the number line is of the form root m. Only few points on the number line is of the form root m, where m is natural number. Hence it is false. Clear up? So right, false. Because every point on the number line, like here there are many points which do not represent because here between root 2 and root 3 or root 3 and root 4, root 5 and root 6, any number can be taken. Here I write between root 2 and root 3, many points are there. Which do not represent root m. Got it? This is the justification for second one. Now we'll move on to third. Third one is every real number is an irrational number. Every real number is an irrational number. Look here, just we have already come to know that if it is a real number, it contains both rational and irrationals. Here they have given that every real number is an irrational number. I'll write the rational numbers like 2, 3, 4, irrational number, root 3, root 2, root 7 and so on. These are all together real numbers. Do you call every real number is an irrational number? Then do you say root 2 is an irrational? No. Root 3 is an irrational? No. Root 4 is not an irrational. Hence it is false. Answer false. And you can give the justification that because the numbers like 2, 3, 4 and so on, 4 are real numbers. Real numbers, but not irrationals. Got it? Now, let's move on to second question. Second question is like this. Please copy with me. The square root of all positive integers irrational. If not, give an example of the square root of a number that is a rational number. Just to go through the given statement, are the square root of all positive integers irrational? All right, some of the positive integers like root 1, root 2, root 3, root 4, root 5 and so on. Do you say square root of positive integers, square root of 1, 2, 3, 4 and 5, they are all positive integers. And do you say them irrationals? What is the value of root 1? It is just 1. Root 2 as it is, root 3 as it is, root 4, 2, where 1 and 2 are rationals but not irrationals. Hence, you can say that the given statement is wrong. The question is, are the square root of all positive integers irrational? Hence, you can write that no. Answer is no. The square root of all positive integers irrational. Then it has been given that if not, give an example for the square root of a number that is a rational number. Example can be taken as here root 4, it is 2. 2 is a rational number, is a rational. You can go for taking some more examples like root 9. Root 9 is 3. 3 is a rational number. Understood? Next. Third question. It has been given that show how root 5 can be represented on the number line. Just we have already come to know how to represent root 5 on the number line. Here, third one, it is already represented. Then fourth question, they have given a classroom activity that is constructing the square root spiral. Constructing the square root spiral. Square root spiral. Yeah, this is. Already I have given you information about this. That is about Theodorus V. So you have to take a sheet of paper and go for constructing or locating up to root 17. Definitely you will get exactly a spiral. In bracket I will write Theodorus V. Now, so exercise 1.2 has been completed. We will move on to the next part of the chapter. Now, we will move on to the next part of the chapter. It is real numbers and their decimal expansions. Write down, cite heading, real numbers and their decimal expansions. Just I go for taking some of the examples. Keep observing them. Example is first one. It is 1 by 8. What is the value of this? On dividing 1 by 8, you will get 0.125. Second one. You may go for taking 25 by 4. Now 4 6 are 24. 1 will remain. Put decimal and take 0. It becomes 10. 4 2s are 8. 2 will remain. 20. 4 5s are 6.25. Third one. You are very familiar with a rational number 22 by 7, which is the value of pi. Then it can be written as on dividing 22 by 7, you will get 3.142857. 142857. If you go for actual division, you will get the numbers like this only, no doubt. Similarly, I go for another one. It is 1 by 3. It is 0.3333 and so on. Let me go for taking one more example that has been given in the textbook. Here they have given the value of root 2. Root 2, it is 1.4142 and so on. Just observe these values. I have taken the rational numbers and their values are written, and all these values are in decimal form. Say 0.125, 6.25, like this. And in every decimal number we have two parts. One is before the decimal, whole number part, and after the decimal, it is a decimal part. In first two examples, you can come to know that there are countable digits in the decimal part. That means there is end for division. Hence, we can say that it is terminating. Whereas in these cases, there is no end at all. It is continuing. So we can say that it is non-terminating. So from this we can come to know that there are different types of decimal numbers. Let me go for giving you the flow chart of decimal numbers. And meanwhile, you can just go for copying these examples by pausing the video. Hope you all have copied this. Here I'll write side heading flow chart of decimals. Here I'll write decimals. In decimals, there are mainly two types. One is the decimal number in which countable number of digits, it is terminating decimal expansion. If there is no end at all, it is called non-terminating decimal expansion. Here I will go for dividing this into two parts. You can also write with me. It is terminating decimal expansion, and this is non-terminating decimal expansion. Non-terminating decimal expansion. And another thing you can notice that in non-terminating, here some part of a non-terminating decimal expansion is being repeated. You can notice that here 142857, 142857. Again next 142857. Here 0.3333 and it can be continued. So as it is called the repeating block, and we can say that it is recurring, non-terminating, recurring. What about this? It is non-terminating. Here digits are not being repeated. Hence we can say that in non-terminating decimal expansion, again two types. One is recurring and another one is non-recurring, or repeating and non-repeating. Recurring decimal expansion and another one is non-recurring decimal expansion. If you go for taking again the non-terminating recurring decimal expansion, here whatever 3.142857, 142857 is there, it can be written like this, 142857. See, this is the repeating block. I have represented by drawing a line on that, or that. Next, 0.333 is there. I can write 0.31 in this. Here, the repeating block has started from the first place only. Such recurring decimal expansion is known as pure decimal expansion. So in recurring we have two types. One is pure recurring decimal expansion. Another one is it's not impure. If I write, suppose I'll just go for taking some value. It is like this, 0.123333 is there and so on. This can be written as 0.123 bar. Now, the repeating block has been started from the first place. It may start after 1 or after 2, after 3 places. Such decimal expansions are known as mixed So this is the flow chart. So in decimal expansion of a number, we have different types: terminating and non-terminating, recurring, non-recurring, pure and mixed. So here actually we have taken real numbers that includes both rationals and irrationals. And one more last information will be given. Just observe it. Here I'll take the value of 22/7. How much it is? It is 3.142857. 142857. 142857. How long you will write? As I said earlier, if it is repeating block is there, it can be written like this: 3.142857 bar. So the part of it which is being repeated, to represent that I have put a bar. Clear up? And here in this, whatever the repeating block is there, which is that repeating block? 142857. 142857. And this is called period. Here I'll write 142857 is period. But how many digits are repeated? Count it. 1, 2, 3, 4, 5, 6. And 6 is called length. 6 is called length. Got it? So just we have come to know period and length. So I'll write side heading period and length in decimals. Period and length in decimals. Hope you all have understood, and you have to copy. Again, whenever I ask you to copy, please pause the video, then you go for copying it. So before going to conclude the class, just let me tell you one important thing. Whatever the syllabus we are covering, please work out on the same day itself. Please don't go for keeping it anything pending. It will be burden for you. And today we have learned an important concept, that is representing some of the irrational numbers on the number line, particularly root 5 by spiral method, root 5 by horizontal method, and root 17. So these are very important, should be learned. And also we have different types of decimals. Just you can go through this, and further information will be given in the next class. And one more information will be given to you now. From past 3 days we have completely focused on mathematics, and the next 3 days will be used for science. In between, 1 day will be used for conducting the test. The test will be conducted tomorrow on the chapter number system, and the syllabus is what I have covered in 3 days up to here. Okay, with this let us stop. Thank you.